In this video, we're going to look at how to actually solve for sides in similar triangles, because then we can connect that to application problems that occur in real life. Okay, so just to recap, triangles are similar if they have the same shape. The only difference is their size, really. So all of the angles have to be equal, so the corresponding angles have to be equal, and then the corresponding sides have to have the same ratio. I also want to remind you from last year that angles can be stated either as a single letter or as 3 letters. So for example, angle A in this magenta triangle, okay, you can write it as angle A like this, or you can write it as BAC, or even angle CAB, as long as the middle letter is the angle you're looking for. Okay, same thing as angle B over here. We can write it as ABC to create the angle, or CBA. Or angle C can be written as ACB as long as that middle letter is the correct angle we're looking for. Okay. Also, just a reminder for similar triangles, if I were to create my similarity statement, it gives me a lot of information. So for example, for these two triangles, triangle ABC is similar to triangle DEF. And just looking at the statement, I can see that angle A is equal to angle D. Angle B, let me use a different color. Angle B is equal to angle E, and angle C is equal to angle F. So it gives me all of the information about the equal angles, and it also gives me information about the corresponding sides. So AB matches with DE. BC matches with EF. And then the outsides. AC matches with DF. Okay, so your similarity statement gives you so much information. Okay, let's try a few examples where we actually solve for sides. Now, if a similarity statement isn't given to you, you might want to create one yourself, even if it doesn't ask you to. But in this case, it does tell us prove the two triangles are similar and then state the similarity statement. So in this case, they tell us which angles are equal to each other, so we can start with that. Angle P is equal to angle N because of the single curved line, the notation. Angle B is equal to angle T because of the double curve. And then angle K is equal to angle D. So we use the angle-angle condition. Now our similarity statement, remember, we're just going in order of our angles. So PBK is similar to NTD. BK, similar, triangle, NTD. Now once we have this, we can solve for our sides. Now I like to use a highlighter just to color in my matching sides before I create a proportion to solve. Okay, so what I'm going to do, PB is going to match with NT. So I'm going to go to my highlighters and I'm going to highlight those sides. So this side matches or corresponds to this side. What else do we have? BK, so position 2 and 3, corresponds to TD. BK is the 7 and TD is the A. And then the leftover one, the outsides, PK corresponds with ND. So the 8 and the 6.4. Now in order to solve for similar triangles, you have to create a proportion, and you can only solve for one variable at a time, or one unknown at a time. To create a proportion, you're going to create two corresponding side ratios, okay? And you always want to have one of your fractions as a full pair, a full match. So if I look at PK and ND, both of those side lengths are given to me. So I'm going to create a ratio out of it. 8 over 6.4 is equal to, and then I'm going to have another one on my right. Now, in this ratio, I put the left triangle on top. I have to make sure I'm consistent and do the same in my second ratio. So I'm going to solve for A first, and A is my blue pair, so the BK and the DT. So that ratio is going to be 7 over A. And it's important that you put the 7 on top because I want to be consistent and keep the left triangle on top and the right on the bottom. And now I can cross multiply. So 8 times A is equal to 7 times 6.4, which is 44.8. Now I can divide both sides by 8, and I'm going to get 5.6. And it doesn't give us units, so I'm just going to keep it like that. Now I do the same thing for side B. I'm still going to stay with that original 8 over 6.4. I don't want to use the blue sides, even though I have 8, just in case I made a mistake with my variable. Okay, so 8 over 64. Now, because I'm solving for B, I'm going to look at BP and NT. So that's going to be 6 over B. I just like color coding because it's more visual and I can see the matching sides a lot better than always going back to that similarity statement. I just have to deal with it one time by color coding, and then I can be on my way and create whatever proportions I want. So now I cross multiply 8 times B and then 6 times 6.4, which is 38.4. Just like before, divide out that coefficient of 8, and B is going to equal 4.8. And there we go. So prove similarity to create your similarity statement and then set up your proportions. And again, I recommend doing the highlighter trick just so you can see your corresponding sides more clearly. Let's try another one. So here I have rotated angles. I see I have parallel sides, which means I'm probably going to have some Z rules or F rules. And let's see what we can find. I have an F pattern right over here, okay, which means angle B and C are equivalent. So angle B is equal to angle C. I'm going to write that in. And then I have another one in the other direction so that A and D are equivalent. So angle A equals angle D. And if I really want to, I can write the last one. I don't have to because it's automatically equal. But the two angle E's would be equivalent just because they're opposite angles. So now my similarity statement would be BAE is similar to triangle CDE. Now I can start color coding my matching sides. So BA and CD would match. So those are my two parallel sides. And then AE and DE would match. So that would be this side and this side. And then BE and CE. So that would be those two sides. Now that I have my matching sides, I can see where do I have a full pair. And if I look here, my blue, so AE and ED, have a full set of information, so I can create my first ratio, 5 over 2. So I'm putting the left triangle on top again. And if I want to solve for A first, that's my green lines, so that's going to be A over 3. And the minute you have that set up, now it's just that basic cross multiplication. So 2 times A and 5 times 3. And then we can divide up the 2. And our A value is going to be 7.5. And let's do the same thing for side B. I'm going to use the same 5 over 2, but now side B is in my red lines. So that's BA and DC. So I'm going to have B over 1.5. Again, B is going to stay on top so that we have that left triangle on top. Now we can cross multiply. 2B is equal to 5 times 1.5, which is 7.5, and divide out the 2 just like before. And we're going to get 3.75. And that's it. Okay, let's do one more example together before you try a few on your own. So here I have the triangle within the triangle, so a nested example. So I have triangle ABC here, and then ADE there. And again, I have a set of parallel lines, which means I'm probably going to use some of my rules. And I see here I have my backwards F and a backwards F right here, which means B and D are going to be equal sides, and then C and E are going to be equal sides. I'm just going to erase that so that when I do my matching sides, I don't have anything in my way. So D and B and C and E, and then A is automatically the same because they share that angle. Okay, so I can write that out. Angle B equals angle D, angle C equals angle E, and angle A equals angle A. So my similarity statement would be triangle BCA is similar to triangle DEA. And I can start highlighting just for the visual part. If you don't want to do this, you don't have to, but I think it does organize your work a lot better. So BC and DE. That's going to be the two bases of our triangles. Then I have CA and EA. CA is here, and then EA is that entire length. It's not just the X, so all the way from A to E, and that's going to be important. And then we have BA and DA, so the 3 and then this entire length. Now when we do this, we might want to write a few little side notes. AD, okay, is going to be the 3 plus the 2, so that side length is actually 5. And then AE, well, it's the 4.5 and the X, so I'm going to write a little expression as X plus 4.5. That's going to help me when I'm solving for my variables later on. Okay, so let's see what full pair we have. I have my green, the 3 and the 5. Make sure you don't do 3 and 2 or else you're going to fall into a bad trap. Okay, make sure it's the actual full length of the big triangle. So I'm going to do small over big, so small triangle, 3 over big triangle, 5. Okay, and now I'm going to choose to solve for A first because it seems a little more basic. And I'm going to have A over 10, and then I can cross multiply here. So 5 times A and 3 times 10, divide out the 5. So once you get to the proportion part, it gets pretty repetitive and hopefully pretty simple. Okay, so A will equal 6 in this case. Now let's solve for X. Okay, again, I'm going to have 3 over 5, but now we're going to have the small side, 4.5 over 4.5 plus X. Okay, so we created a mini expression for AE, and now when we cross multiply, we have to remember about distribution and keeping brackets right now. So I have 3 times 4.5 plus X in brackets, and then 5 times 4.5, which is 22.5. Now I can distribute the 3 in. 3 times 4.5 is 13.5. 3 times x is 3x. And now we can solve our linear equation by bringing the 13.5 over. And when we do that, we end up subtracting. Remember opposite signs, please. And when I do 22.5 minus 13.5, I get 9. Now we can do that final step of dividing out the 3 to get an x value of 3. So that would mean that little portion up here from C to E, that's equal to 3, not the entire big length. The entire length would be 3 plus 4.5, so 7.5. So if they asked you for AE, you could say it's 7.5. So now we've looked at the 3 main examples. So when you have triangles side by side, when you have those rotated angles that create the Z pattern, and when you have these nested triangles where you use the F pattern to prove similarity. Okay, so I want you to try the first example on your own. Okay, this is similar to the first example we did together. I want you to prove similarity using the angles and state your similarity statement, and then solve for sides y and z by setting up your proportions correctly. Again, I recommend you use a highlighter just for that visual. So if you're stuck, here is your similarity statement. P and X are equal, Q and Y, R and Z, and that is my statement. Now I can start matching my sides. So I have PQ and XY, PQ, XY. I have QR and YZ, QR and YZ, and then I have PR and XZ. You don't even need your statement at that point, it's whatever's left. Okay, if you have that right and you want to move on, go ahead, set up your proportion. If you've already seen it, just continue with the video. Alright, so your first proportion was 4 over 3 because the blue lines were the full pair. And then I did 7 over y. You could have done the opposite. You could have done 3 over 4 equals y over 7 and you would have gotten the same thing. Okay, just make sure you're keeping the same triangle on top. Okay, and when you cross multiply, you get 5.25. for solving for z, I did 4 over 3 again, is equal to 6 over z for the red pair. Cross multiplied and I got 4.5. Okay, if you made any mistakes, check to see where it was. Did you make a silly mistake with solving proportions? Did you make a mistake when you were identifying the matching sides, or just when you actually try to prove the similarity? Okay, I want you to try number 2 now. So we have that rotated examples with parallel lines. I want you to find which angles are equal to each other and write out your similarity statement. Okay, before you move on, you can check with me to make sure you have the right similarity statement. All right, so A and E were equal because we had a Z pattern right here. B and D were equal because, again, another Z pattern. And then C were equal because they were opposite angles. So my statement was ABC is similar to EDC. And now we can match up our corresponding sides and create our proportions. So pause the video again and continue with the actual solving part. All right, so your corresponding sides should have been AB with ED for my red, AC with CE with the green, and then BC with CD for the blue. And now my full pair is the 3 over 12. And if I'm solving for x, that matches with the 3.25, and then I cross multiplied to get 13 for x. Now B is actually a lot easier because they're asking us to solve for an angle. And we already stated that angle B and angle D were equal to each other because of the Z rule, or alternate angles, which means B was just equal to 75 degrees. So solving for angles is usually the really fast one. Solving for sides just requires a little extra work because you have a proportion to set up. Okay, and now we have that nested example of a triangle within a triangle. Again, we have those parallel lines, so you're going to want to use a rule. So I want you to tell me what the equal angles are, create your similarity statement, so pause the video, and then check your similarity statement with me just before you move on so that you don't carry a mistake going forward. Okay, so here's your statement. A and D are equal because we have an F pattern right over here. Okay, B and B are equal because we have another F pattern, and then angle C is shared, so they're automatically equal. So your statement was triangle ABC is similar to DEC. Okay, now go ahead and solve for Y and Z. Be careful here. You might have to create that extra linear expression to represent one of the sides. And I'm sorry, you're actually solving for sides X and Y, not Y and Z. Okay, so the 11 and the 7 were the full pair, so the bases. So I put 11 over 7, so big triangle over small triangle, and then the blue lines were Y and 13. When I cross multiplied, I got approximately 20.4, so don't forget about that squiggly line for the approximate. Okay, for AC, that length is not equal to x, it's equal to the x plus the 15, so make sure you're using that in your proportion. So again, I used 11 over 7. And then for my second fraction, I did x plus 15 over 15 because I was doing big over small. Now when you cross multiply, you have to be careful here to keep your fractions for the x plus 15 expression so that you can distribute the 7 into both terms, or else you're going to mess it up. And now you're just solving the linear equation. Bring the constant over. Don't forget to flip the sign, then divide out the coefficient to get approximately 8.6 for that little x portion. Okay, let's do a little word problem. A clever outdoorsman, whose eye level is 2 meters above the ground, wishes to find the height of a tree. He places a mirror horizontally on the ground 20 meters from the tree. So that's this portion right here. Our mirror is right there. There's the tree. That's the distance between the two. And finds that if he stands at a point C, which is 4 meters from the mirror, he can see the reflection of the top of the tree. How high is the tree? So there's his distance from the mirror, there's his height, there's the distance from the mirror to the tree. The first thing we want to do is prove that these two triangles are similar, and then state our similarity statement. Now, you have to make a few assumptions here. The first is that the tree and the person are upright, so that they form a right angle with the ground. That's an assumption that we have to make, and we're assuming it's a perfect world. So we can state that angle C is equal to angle A. Now the next set of equal angles, we have to rely on the law of reflection, which hopefully you saw in physics when you were doing optics, but it pretty much states that the angle of incidence is equal to the angle of reflection, and your angle of incidence is this angle right here. So looking down, the guy looking down into the mirror, that's your angle of incidence right there. The angle of reflection is what he sees from the mirror, so that would be there. Okay, so this angle and this angle are equal. So angle B is equal to angle B. I'm going to make a little note. Law of reflection. So whenever there are mirrors involved, you can assume those two angles are equal because of the reflection and the beam. Okay? Which means our leftover angles have to be equal just by the fact that the three angles in a triangle have to add up to 180. So angle P has to equal angle Q. And now we can state that triangle CBP is similar to triangle ABQ. Now we can figure out the height of the tree, which I'm just going to label H for when I set up my proportion. Okay. For this one, it's pretty easy to see which sides are the matching ones, but CB and BA are corresponding, and then BP and BQ are corresponding, but these two sides really have no relevance to us because they don't have any measurements. What we care about is CP and AQ, so the height of the person and the height of the object, in this case the tree. So my proportion is going to be the 4/20, for my full pair, which is the basis, and then the heights are going to create the other one, 2/h. And now we can cross multiply, so that we have 4h equals 40 from the 2 times the 20, divide out the 4, and I get a height of 10 meters. And in this case it is a word problem, so therefore the tree is 10 meters tall. And that's it for solving similar triangles. Make sure you know how to state similarity and prove similarity, and then you're just matching sides up to create your proportion and cross multiply to solve for whatever unknown you need.